Imagine for a second that you are a highly trained secret agent. Your mission? To infiltrate a highly hostile, rigorously guarded facility known as the exam hall and extract maximum marks from a Cambridge computer science paper in 20 minutes or less. Whether you are tackling the 0478 IGCSE, the 2210 O Level, the 0417 ICT paper, or even stepping up to the 9618 A Level, the security system you're up against is the exact same: the Cambridge Examiner's Mark Scheme. Welcome to this explainer. Today, we're completely transforming how you tackle topics like image resolution and color depth. We are moving you away from basic rote memorization and upgrading you to a high-scoring strategic application mindset. Now, I want you to picture a real past paper question right in front of you. We've got 2 recruits taking this exam. First up is Alex. Now, Alex's entire strategy is to just overload the page with raw computer science facts. I call him the brute force dictionary. He writes down absolutely everything he has ever learned about pixels, binary, hexadecimal, you name it. But he provides absolutely zero analysis of the actual scenario. So what happens? His massive, irrelevant data dump that's mercilessly crossed out by the examiner, red ink everywhere. Then we have our second recruit, Sam. Sam is the speedrunner. He rushes the extraction. He's skimming the paper, he spots the words color depth, and his brain just autofills the rest. He completely misses the crucial command word, which was evaluate, and instead he just scribbles down a basic one-sentence definition. And the result? More red ink. Both of these recruits completely failed the mission. Why? Because they didn't understand the examiner's security system. They didn't know how to play the game. Well, today, we are going to fix that once and for all.
So, let's look at your mission briefing. Here is our step-by-step tactical blueprint for this explainer. First, we'll uncover the rote memory trap. Second, we'll build up the 3 layers of understanding. Third, we'll deploy the method mark strategy. Fourth, we'll go on the defensive and look at avoiding common examiner traps. And finally, we'll equip you with the 4-question check. Let's kick things off with Section 1, the rote memory trap. We need to look at why simply knowing the vocabulary is a massive liability. Let's circle back to our first recruit, Alex. Alex is a hard worker, right? He spent literally hours with his flashcards. He memorized perfectly that image resolution is the concentration of pixels within a specific area, and he knows that color depth is the number of bits used to represent the color of a single individual pixel. He knows the facts. But when the exam threw him a curveball and asked him to justify the use of a lower color depth for a web-based graphic on a smartphone, he completely froze. This is the danger. When you just memorize a term, you are creating a very fragile piece of data in your brain. A truly strong, high-scoring answer begins by understanding the exact digital problem involved. You need to know the practical consequences for a real user or a real computer system. That gives you a genuine, logical reason to learn the content before any technical terminology is even introduced. I want you to think about it logically for a second. Why did computer scientists even invent the concepts of image resolution and color depth in the first place? They didn't do it just to torture you in an exam. They did it to solve real-world digital problems. High resolution and high color depth solve the problem of visual fidelity. They make a photograph on a 4K monitor look incredibly crisp and photorealistic. But solving that problem creates a brand new problem: absolutely massive file sizes. So, intentionally lowering the resolution and color depth solves the problem of slow transmission speeds over a network, and it solves the problem of excessive storage consumption on a device with limited memory. If you can understand this push and pull, this fundamental digital tug-of-war, you can answer literally any application question the examiner throws at you. Think about the vocabulary list approach versus the digital problem solver approach. It's night and day. If you use the vocabulary approach, you see the phrase 24-bit color on the exam paper, and your brain immediately jumps to 16.7 million colors. End of thought process. You just state the fact with zero context. But a digital problem solver approach, that student sees 24-bit color, and their analytical mind kicks in. Okay, 24 bits? That means 3 bytes of data for every single pixel. If this is a high-resolution image, that's going to create a mathematically massive file size. If the exam context is a mobile e-commerce website, this is a huge problem because it will eat up the user's mobile bandwidth and severely increase page loading times. Do you see the massive difference there? The vocabulary list gets you 1 pity mark, maybe 2 if the examiner's feeling generous, but the problem solver? They extract every single available mark because they are actually addressing the examiner's real-world scenario. Moving right along to Section 2, 3 layers of understanding. This is where we start building your exam-ready mindset. To reach that elite digital problem solver mindset, you can't just jump straight into writing massively complex technical paragraphs.
It just doesn't work. Our explainer source material outlines a highly effective logical progression. The ideal progression moves through 3 distinct layers, starting with simple everyday language, deliberately adding correct subject vocabulary, and finally shaping it into a structured exam response that consistently scores marks under intense time pressure. Layer 1 is simple language. In your head, you might say, well, if I make the picture clearer and add way more colors, the file gets super big and takes forever to download. That's factually true, but it doesn't score any marks at Cambridge level. Layer 2 adds the technical vocabulary. You upgrade that thought to, increasing the image resolution and color depth increases the file size, which requires more bandwidth to transmit. Okay, much better, we are getting warmer. But layer 3, the exam response, is where the absolute magic happens. This is where we break down the computer science-specific assessment objectives and introduce the Peel framework. Point, evidence, explanation, link. Now, I'm going to put a 30-second timer on the clock in a moment for you to spot how this is structured. A flawless Layer 3 answer looks exactly like this. Increasing color depth from 8-bit to 24-bit triples the number of bits required per pixel. This significantly increases the total file size of the image, making it entirely unsuitable for the client's low-bandwidth mobile application due to excessive loading times. Boom, maximum marks extracted. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Welcome back. Let's dive into Section 3, the Method Mark Strategy. It is time to look at the exact, surgical method to attack these questions. The ultimate secret to transforming those brutal red pen marks into beautiful green check marks is understanding exactly what the examiner is permitted to give you points for. You have to remember, they are bound by a highly rigid, highly specific mark scheme. Your job in that exam hall isn't to write a compelling, creative essay. Your job is to systematically trigger the specific technical causes in that scheme. And there is a massive, distinct difference between describing something and explaining it. If you see command words like state, identify, or describe, the examiner is just asking what it is. Describe color depth simply means stating it's the number of bits used to dictate the color of a pixel. Easy. But command words like explain, evaluate, or justify, those demand significantly more. They want to know exactly how it works computationally and why it matters in this specific digital universe. Our source material makes a brilliant point here. If a student only describes, the answer sounds safe, but it's incredibly shallow. But on the flip side, if they excitedly jump straight into an explanation without clearly naming the concept first, it sounds scattered and confused. You must anchor your answer by identifying and describing the concept, and then propel it forward by explaining its technical impact.
So, the source material reveals this fascinating, disciplined 4-step path to structure your answers logically, rather than just writing down facts in a totally random, panicked order. This is the absolute heartbeat of the Peel framework applied directly to computer science. Step 1. Identify the demand. You must decode the command word first. Is it asking for a process, a hardware choice, or an evaluation of 2 options? Step 2. Classify the concept. Clearly state the technical term. In our case today, that's image resolution or color depth. Step 3. Explain the sequence. Listen closely. This is absolutely critical for computer science. It is a strictly logical subject. Step A causes Step B, which causes Step C. Higher resolution means more pixels per inch, which means more binary data to process, which inevitably means a dramatically larger file size. Do not jump backwards and forwards in your logic. Keep it linear. Step 4. Connect to context. You must link that logical sequence directly back to the specific scenario they gave you in the question. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, acetheexams_IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's talk about the golden rule. Context. Generic textbook responses rarely, if ever, gain full marks in the higher level questions. If the question is set in a busy retail environment, or an automated factory, or highly secure banking system, your answer must stay strictly inside that specific real-world context. This is exactly where so many students accidentally throw away easy marks. Let's do a live rewrite of our recruit's answer right now. Imagine a student writes a technically flawless, totally theoretical paragraph about how reducing color depth directly reduces file size by lowering the bit count per pixel. Great theory, but they totally forget that the exam question was specifically about a professional photographer uploading massive wedding photos to a remote cloud server over a cellular network. If you don't explicitly mention the photographer, the remote cloud server, or the impact on upload speeds over cellular, you are literally leaving marks on the table. You haven't finished the extraction. The examiner needs absolute proof that you can apply your textbook theory to a messy, real-world reality. That is the computer science success blueprint.
All right, Section 4, Avoiding Common Examiner Traps. Even with a perfect strategy, you need to play heavy defense. Let's navigate the minefield. Welcome to the interactive workshop segment of this explainer. In the exam hall, the ticking clock is your worst enemy, and panic leads directly to unforced errors. The principal examiner warnings from Cambridge consistently highlight the exact same recurring mistakes year after year after year. They are vague wording, confusing similar terms, missing process steps, ignoring the given context, and stating advantages without giving any technical reasons. Vague wording is an absolute killer. Writing something like, "It makes the picture look better," instead of, "It increases image fidelity by increasing pixel density," will cost you the grade. Let's do challenge 1 right now, the data scan. Imagine I'm putting a 60-second visual countdown timer on the screen. I'm showing you a complex data table mapping different file formats, bit depths, and compression types. The question is, what happens to the underlying data when we move from an 8-bit indexed color palette to a 24-bit true color palette? The core trend you need to extract in those 60 seconds is that the file size literally triples because the byte requirement per pixel goes from 1 to 3. Now, let's roll right into challenge 2, find the flaw. I'm going to show you a flawed sample paragraph from our rushing recruit, Sam. Sam wrote, "To make the client's new website load much faster, the developer should use a much lower resolution so the picture is smaller." Did you catch the flaw? I'll give you a second. The fatal flaw there is vague wording. Saying the picture is smaller is horribly ambiguous. Does smaller mean the physical dimensions in centimeters on the screen, or does it mean the file size in bytes on the server? The examiner will never, ever give you the benefit of the doubt. You must explicitly state, "reduces the overall file size in byte." You also absolutely need to quickly spot theoretical contrasts, things like memory versus storage or data versus information, because misunderstanding these rigid boundaries will often hijack and ruin your entire answer. The source text heavily emphasizes that computer science reasoning is built entirely on these foundational distinctions. If an exam question asks how a high-resolution, uncompressed image affects storage, and you start writing a beautiful paragraph about how it fills up the RAM and slows down the CPU cache, you've crashed the mission. Storage is your secondary storage, your hard drive or solid-state drive. RAM is your primary active volatile memory. A high image resolution eats up storage when it's saved to the disk, but it eats up memory when it's actually opened in Photoshop for editing. You must use precise terminology. Let's do challenge 3, speed writing. You have 30 seconds. Why would a web developer specifically choose a 16-bit color depth over a 32-bit color depth for a tiny mobile game logo? The timer is ticking. If you wrote a BL paragraph that focused on the reduced bandwidth requirements leading to significantly faster load times for a mobile user on a 4G network because the logo doesn't require photorealistic 32-bit transparency, then you absolutely nailed it. Finally, we reach Section 5, the 4-question check. This is your immediate, actionable tool to verify your exam readiness today. So we have successfully decoded the command words, we've actively applied the Peel framework, and we've safely navigated the examiner's trap minefield. Now we need a final diagnostic tool. How do you actually truly know if you have mastered a topic like image resolution? Before you confidently walk into that exam hall, let me introduce you to the final system. 3 rules guarantee top marks: command word decoding, Peel framework application, and the time management matrix. To test if you're ready, let's run the topic of color depth through our 4-question diagnostic check. Prompt 1, what is it? You answer, it's the exact number of bits used to represent the specific color of a single pixel in a digital image. Prompt 2, how does it work? You answer, allocating more bits allows for exponentially more binary combinations, which dramatically expands the palette of available colors, but it inherently requires storing more data per pixel. Prompt 3, where is it used? You answer, it's a critical factor in high-end image rendering, digital photography, and optimized web design. Prompt 4, why is it better or worse than an alternative? You answer, 24-bit color is significantly better than 8-bit for photorealistic images because it completely prevents visual color banding, but it is vastly worse for simple, flat color logos because it unnecessarily bloats the file size, wasting valuable secondary storage and network bandwidth. If you can speak that entire logical sequence out loud right now without looking at your notes, your knowledge is officially bulletproof. When you repeatedly and deliberately connect these abstract concepts to the familiar technology you use every day, like your smartphone, the websites you browse, or the secure banking systems your parents use,
You begin to intuitively remember the underlying reason the concept exists, not just its textbook label. This quote from our source material really is the ultimate, undeniable truth of computer science. You aren't just memorizing arbitrary theories for a test. You are learning exactly how the massive digital world you interact with every single day actually functions behind the glass. The next time you look at a high-res image taking way too long to load on your phone when you have 1 bar of signal, you shouldn't just be annoyed. You should be actively seeing the invisible mathematical battle between image resolution, color depth, and limited network bandwidth. That is real-world transfer.
I want you to apply this tactical blueprint to your revision sessions immediately, starting today. Start actively converting your static, memorized facts into high-scoring, context-aware, peel-structured exam answers. Just think about the massive unfair advantage you now have over students like Alex and Sam. You aren't just blindly memorizing definitions hoping they show up. You are forensically analyzing digital problems. You are stacking your 3 layers of understanding. You are executing the precise peel method, and you are dodging the examiner's traps with absolute precision. Take this 4-question check and go apply it to data transmission or logic gates or cybersecurity hardware right now. The Cambridge Mark scheme is no longer a terrifying mystery to you. It is just a map, and you now have the exact tools to read it and extract your grade. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel AC Exams at ACExams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @ACExams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. AC Exams, your Cambridge success starts here.